Hello and welcome back to this video series regarding the Intermediate Math League of Eastern Massachusetts. Today we're going to be starting up the material on Meet 5 of IMLEM. Now we're starting a new meet today, and in Meet 5 you do get to use a calculator because the questions are quite difficult and some of the calculations are difficult to do in the head. So you can use any calculator for any of the problems that come up in this section. Now, for those of you who are new to IMLEM or new to my videos, I'll just quickly be going over the structure and categories of IMLEM in my videos in relation to that. So in IMLEM, there are 5 competitions total, each of which tests different material. And at each of those 5 competitions, there are 5 different categories that you'll compete in, which are mystery, geometry, number theory, arithmetic, and algebra. So the mystery section is just a mystery, which is why it's called mystery, and we can't really cover the material for that because we never know what's going to be on it. But for the other 4 sections, we can cover the material, which is why I'll be starting with geometry today. Now, in terms of labeling my videos, this is how it might go. So, for example, if I label my video 4.2.1, that'd be referring to first the competition number, so as in competition 4, the category is the second number. So you'll notice that the categories are numbered over here. So geometry is number 2. So that's saying, okay, well, this video is talking about Meet 4 geometry. And then I just break them down into different sections for organization. So the next number is just the first section of that geometry. So today's video will be labeled 5.2.1 because it's Meet 5 geometry, which is the 2, and then 1, because we're just starting the new section. So let's get right into geometry. Okay, so the first topic that comes up in Meet 5 geometry are surface area and volume. Now, we're actually just going to be working on volume today because the volume questions can get quite difficult, and we'll work on surface area next time. But unfortunately for both of them, you're just going to have to memorize a bunch of formulas, which is why I kind of grouped them together in the same group of geometry. So volume is defined as the amount of space inside an object. So if you had a cup, the volume would be how much space there is inside that cup, or you can measure that by pouring in water and seeing how much water you could fit inside that cup. So the volume is just the amount of space. Now, to calculate volume, that depends on the shape of whatever object you're talking about. So unfortunately, we do have to memorize all these formulas. A lot of them are intuitive though, so they just make sense, and it might help to remember them in that way. So the first volume formula is of a rectangular prism. So a rectangular prism is one that kind of looks like this. So you have straight lines, and it's just rectangles on all sides. So for example, a cube would be a type of rectangular prism because it has all flat sides and it has all 90-degree angles for the sides. And so this is a rectangular prism here, and the area formula is length times width times height. So where length is the volume, length is the length of this side, width is the length of that side, and then the height is just the height of this side. So if you multiply those 3 together, that will get you the volume of the rectangular prism. So just as a quick example, if the length of this one was 2, the width was 1, and the height was 2, we would do 2, which is the length, times 1, which is the width, times 2, and that gets us to 4. So the volume would be 4 cubic units. All right, so the next formula is the formula to find the volume of a cylinder. So this one's a little bit more complicated than the one of a rectangular prism, but it does follow the same principles. And that's that you take the height and you take the area of the base and you multiply them together. So let me show you an example. So here I have a cylinder, and I'll draw one really quick. It's not going to be the best drawing. Okay, yeah, that wasn't great. But here we have a cylinder. So the height, this is the height here. And then if you just take the area of the base, which is this, and multiply it by the height, then you're going to get the volume of the cylinder. So that's why the volume formula is pi r squared h. Because in order to find the volume of the base, which is a circle, well, the area of a circle is pi r squared. So if you have the radius of the circle, and then you do that radius squared times pi, then you get the area of the base, and then when you multiply that by the height, that gets you the volume of the entire cylinder. And so that's actually going to be the theme that we see for all of these volume formulas. That also includes this one, and I'll break it down real quick, that if you find the volume of the base, which of a rectangular prism is just a rectangle, so that's width and length, you multiply them together. So L times W, that's the volume of the base, and then multiply it by the height, that also gets you the volume of the rectangular prism, which is why we have L times W times H. All right, so the sphere is the odd one out. It doesn't have a base, so there's no intuitive way to do this. You just kind of have to memorize the formula. It is 4/3 times pi r cubed. So if I had a sphere here, and mind me, I'm not very good at drawing spheres. Okay, so here's my sphere, and if my radius was equal to 3, then I would do 3 cubed, because that's radius cubed, times pi, and they will give you a, they'll tell you what to use for pi in all the questions. So they might say, use pi as 3.1 or use pi as 3.14, and you just follow whatever they give you for pi. And then times 4/3. And if you plug this into your calculator, I'm not sure what it'll get, but that will be the volume of this sphere. All right, and then finally, we have the cone and triangular prism. And I'm actually going to clear everything so I have a little more room to draw. All right, so for the cone and triangular prism, I decided to group these two together because even though they're different shapes, where a cone is like this and has a circular base, and a triangular prism is like this and has not a circular base, it has a triangular base. That wasn't a great triangular prism, but we'll pretend it was fine. Okay, so even though they have different bases, they have the same area formula, or volume formula. I did not like that, so I'm going to redraw it. Okay, there we go. It's like a pyramid with a triangle base. So they have the same volume formula in essence. You find the volume of the base, which for the cone is just the volume of a circle, and for the triangular prism is just the volume of a triangle, and then you multiply that by 1/3 of the height. So for example, if I had a cone here, and in my cone, I had my radius of my base as 2, then I would do pi r squared to find the area of my base, because it's a circle. So I do pi times 2 squared, because 2 is my radius, and that gets me to 4 pi. And then if my height was 5, actually I'm going to make my height 6 to simplify calculations. So if my height was 6, then I would do the volume of the base, which is 4 pi times 6 times 1/3, because it's 1/3 of the height. And then when you multiply that all out, that gets you 8 pi units cubed. And the same for a triangle. And just quickly to review the area formula of a triangle, it is area equals 1/2 base times height. So if we had a triangular prism here, and I'll do my best to draw it. Okay, so we have a triangular prism, and the base here is 2, and the height is 1.5. Then we could do area equals 1/2 times 2 times 1.5. And then that simplifies to 1. So the area is just 1. And then you take the height, which let's say is 3, and you do the volume, or sorry, the area of that base times the height times 1/3. So we do the area of the base, which is 1, times 3, which is the height, times 1/3. And that would get us 1 as our total volume of this triangular prism. All right, so unfortunately, not all volume questions are as simple as just finding the volume of one object, and that will be the answer. A lot of the questions that IMLEM likes to ask have multiple steps, where first you have to figure out how you actually do the question and what volume formulas you need to use, before you can find the answer. So I'm just going to be going over some of the concepts in order to solve those questions with this slide. So I have two examples on this slide. I haven't shown the second one yet, but let's read the first one. This question says, a sphere is perfectly fitted inside a square box. If the volume of the empty space in the box is approximately 102.9 centimeters cubed in centimeters, what is the radius of the sphere? Round your answer to the nearest whole number. All right, so for these questions, really what you need to do is you need to kind of visualize what it's asking you to find or what it's telling you about. So in the first sentence, it says, a sphere is perfectly fitted inside a square box. So first I would visualize a square box. So here's one side, right? And if you need to, you can draw it out. That actually helps a lot. So here's one side, here's two sides, and then here's this completing the cube. All right, and we can't see the other sides, but let's assume it's a perfectly square box. And I know these aren't perfect squares, but we just have to assume. So now it says, if the sphere is perfectly fitted inside a square box, well, that means that the sphere is touching all the sides of this square box. So I'll just draw a sphere inside the square box, and we can assume that it's touching all of these sides here, 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 and on all of the different sides of the sphere, which means that if we find the volume of this box and we find the volume of the sphere, well, all the empty space is only the space that the sphere isn't taking up. So say the volume of the box was 4 and the volume of the sphere was 2, we can just subtract that, and the empty space will be whatever the sphere isn't taking up. So the empty space would be 2. So using that, we can try to find the radius of the sphere. And that's because if we look at this diagram one more time, let me just erase some things. All right, if we look at this diagram one time, you'll notice that the radius of the sphere from the center all the way to the edge is 1/2 the width of the entire box. Because if the sphere is touching on all sides, then your radius is going to be 1/2 of that total length, because it goes only halfway from one end to the other. All right, so using that information, we can now say, first, the volume of the box minus the volume of the sphere equals 102.9 centimeters cubed. So the volume formula for just a square box is length times width times height, because it's a rectangular prism. But we can simplify it a little bit more, because since it's a square box, that means that the length of all the sides are the same. So we're just going to say that the length cubed equals the volume of the box. So I'm going to write VB as in box. All right. And now the volume of the sphere, if you remember the formula, is 4/3 pi times the radius cubed. So 4/3 pi r cubed, and that's going to be the volume of the sphere, which I'll label as VS. So if we take the volume of the box minus the volume of the sphere, that's going to get us 102.9 centimeters cubed. Now, if we just substitute these two formulas in here and do L cubed minus 4/3 pi r cubed equals 102.9, 102.9, we have a problem, because we know our basic algebra skills enough to solve for just one variable. But in this question, we have one equation and two unknown variables, and that's L and R. So we have two methods of trying to solve this. The first method is to use a system and to come up with a second equation and eliminate one variable. But it doesn't really give us enough information to do that, so we need to try something else. And that's what we talked about earlier. We can say that the length of this box is going to be 2 times the radius of the sphere. Because if you think about it, if we have this circle, or we'll pretend that's a sphere, perfectly inscribed inside a box like this, then if we take the center and go to the edge, that's going to be half the distance of that. So the radius is half the distance of the length, which means that the length is actually 2 times the radius, or L is 2r. So now if we say, okay, well, the volume of the box is going to be the length cubed, or 2 times the radius cubed, now we can solve for the radius. So when we resubstitute it in here, instead of saying L cubed, we can say 2r cubed. Make sure you keep the parentheses, because L is equal to 2r, and if you don't keep the parentheses, then you're going to mess up calculations. So now we have 8r cubed, or 8 times r cubed, minus 4/3 pi r cubed equals 102.9. And this is really the part that I want to cover, just getting to this step, because you have to visualize, or sometimes you want to actually draw it out, what they're talking about, and see how different lengths and maybe different areas even relate to each other, so you can come up with an equation to solve for whatever you need to. So right here, we only have one unknown variable, and that is r. And so it's just basic algebra from here. You want to isolate the variable, and eventually you'll get r cubed equals some number. And then if you're unfamiliar with how to deal with cubes, when you have r cubed equals some number, say it equaled, I don't know, say it equaled 27, then all you want to do is hit the cube root button on your calculator. So you want to type in 27 and then hit the cube root button, which is the one that should look like this in most cases. And if you don't have a button that looks like this, then you want to hit the button that looks like this. And what you want to do is you want to type in 27, hit this button, and then hit 3, because it's saying x is equal to 27, y is equal to 3. So then it will get the cube root of 27. And in that case, r would be 3. All right, on to the second question. This one's also a little bit difficult to visualize. It's a 1,000 centimeter cube box of water is filled completely. A triangular prism is put in and water spills down the side. If the base area of the triangular prism is 20 centimeters squared and the height is 6 centimeters, then what is the remaining volume of water in the box when the prism is fully submerged and then removed? All right, so let's think about what we need to find and what it's actually asking. All right, so it's saying a 1,000 centimeter box of water is completely filled. So let's imagine we have a box here. All right, here is our box. Oh, that's not a very good box. Okay, there's our box. And this is filled to the brim with water. So we have water all the way to the top. Now, if we were to place something in this water, like it says a triangular prism is put in, then obviously the water would overflow. It would spill down the side. So when you took the triangular prism out, there will be less water in the box because some will have spilled out. So the amount of water that spills out is actually going to be equal to whatever volume you put in. So if I take a cube that has a 8 centimeter cubed volume and put it inside this box, well, the box can't take in anymore, right? It's already full, so it needs to let out 8 centimeters cubed of water. So the same applies to the triangular prism. If I put a triangular prism in, so here's my triangular prism, mind my drawing. Okay, so if I put this triangular prism in, and this has a volume of 35 centimeters cubed, then since this is already full, in order to displace it, in order to allow that prism in, it's going to have to overflow some amount. And the amount of water that's going to get spilled over the side is going to be equal to whatever volume we put in. So the amount of water that's going to leave is going to be 35 centimeters cubed, which means that when we take it out, our total volume left will be 1,000 centimeters cubed, our initial one, minus the 35 that spilled out, and that would be 965 centimeters cubed of water. So that's the general way you'd go about solving this question. Now, 35 is just a number I made up. That is not the volume of this triangular prism. So what you need to do in this case, and I'm not actually going to go through all the calculations because the point is just to figure out how to solve it. what you'd actually need to do in this case is find the volume of that triangular prism based off the information in the question. So remember, the volume of a triangular prism is 1/3 pi, oops, no, sorry, that's the cone. Volume is 1/3 and then times the base. So 1/3 base height times 1/2. And that's the volume of the base. So if it says the base area is 20 centimeters, well, we have the volume of the base. So, and times height. So we do 20, which is our base area, times 6, which is the height, times 1/3, and that's the volume. And then whatever that volume is, you subtract that from 1,000, and that will be the remaining volume of water in the box after it's fully submerged and then removed. All right, and finally, I have one review question here with a tricky volume question. If you'd like to try it, I'll give you a few seconds to pause the video, and then I'll explain the answer. So the correct answer to this question was 9,333 blocks, which is more than I would expect, but we can do the math to figure out that that's correct. So the question reads, how many 8-inch by 8-inch by 16-inch cement blocks will be required to construct a foundation that's 32 feet long, 24 feet wide, and 8 feet tall? Each wall is 8 inches thick. And thankfully, they give us this nice diagram down here in order to solve the question, because it could be a little bit more confusing if they didn't. All right, so basically what it's asking, and this is the trickiest part, is it's asking how many of these 8-inch by 8-inch by 16-inch cement blocks. So I'll draw one of them to the best of my ability. All right, that looks pretty accurate. So 8 inches by 8 inches by 16. So that's 8. That's 8. And then this long one is 16. So how many of these blocks are required to fill this volume here, to construct this foundation where it's 24 feet by 32 feet by 8 feet? And each of these walls is 8 inches thick on all of the sides, but not on the bottom because it's a wall. So its height is 8 feet of this empty space. But it does have walls on the side that are 8 inches thick, but that's not part of the height. All right, so we need to fill this empty area with all of these cement blocks. And the way you should go about doing this is by using volume. If you can find the volume of this empty area, so we'll call that the volume of the empty area, VE, as in empty, and take that and divide it by the volume of each individual concrete block. So the volume of the empty area divided by the volume of the concrete block, that'll get you the number of blocks needed, or I'm going to write required, to fill the area, or to fill this volume. And that will get us our answer of 9,333. So it seems easy peasy at first. All we need to do is find this volume, find that volume, and then divide them. It's unfortunately not that simple, and that's for two main reasons. The first is the units that they give us. In the question, you'll notice that the dimensions of the cement block is given in inches. We have 8 inches by 8 inches by 16 inches. However, it gives us the dimensions of this big foundation in feet. It says 32 feet long, 24 feet wide, and 8 feet tall. And then it gives us the wall thickness in inches again. So what we need to do first, before we do any calculations, is just choose one unit of measurement to stick to, and stick to that unit of measurement throughout the entire question. And so anything that's not in that unit of measurement, we need to convert to it. So what that means is we either need to do this entire question in feet or do this entire question in inches. And in the end, it doesn't matter, you'll get the same answer, but I'm going to choose inches just because if we converted these inch measurements to feet, we get nasty stuff like 2/3 of a foot, and we don't really want to deal with fractions. All right, so I'll erase that. So first, before we do any calculations or figure anything else out, we need to convert everything to inches. So you can use your calculator for this. What you do is you take anything that's in feet. So for example, this length here of 24 feet, and you multiply that by how many inches there are in a foot. So there are 12 inches per foot. So when you do 24 times 12, that gets you to 288 inches in this length. So I'm going to now write 288, cross this off, and know this is in inches. All right, so the other one that you have is 32 feet. So if you do 32 times 12, 32 times 12 inches per foot, that gets you 384 inches. And I had to quickly grab my calculator to do that because I can't do that in my head. So 384 inches is this length. And then finally, it says it's 8 feet tall, and I forgot about this one. But you have to convert that to inches too. So 8 times 12 is 96, and then 96 inches. All right, so now we have all our dimensions in inches. So we can't just go out and just do 288 times 384 times 96. That will get us a area, but it won't get us the correct area. If you notice, it also says each wall is 8 inches thick. In the actual part of this diagram that you're filling is this inside volume here, right? The length of the entire thing is 288 inches. The width of this entire thing is 384 inches. But the width of this inside area that's contained by the walls is not 288 inches. And in this way, it's not 384 inches. And that's because the walls take up some of that space. They take up 8 inches on each side, which means that even though this entire length is 288, in order to find this smaller length of the inside area, the empty space, we need to take this 288 and subtract the length of each wall on each side. So this this left wall takes away 8 inches, and this right wall also takes away 8 inches. So if we subtract 8 twice, or if we subtract 16, that means that this length is 272 inches, not the original 288. And then if we do the same thing, we have this back wall and this front wall, which each take up 8 inches. So if we subtract that from 384, so 384 minus 16 in total, that gets us to 368 inches. All right, and so now that we've taken that into account, we can do the problem, multiply it out to find that volume, and then we're almost to the answer. And we don't need to subtract 16 from this 96, because remember, it says each wall is 8 inches thick. So there's nothing on top that's taking away this height, and whatever's on the bottom, this floor here, that's not part of a wall. So we can just assume that that's not 8 inches thick, and we don't need to subtract anything. All right, so in order to find the volume of the empty space then, since it's a rectangular prism, if you remember your volume formulas, we do length times width times height, which is volume equals 272 times 368 times 96. And I cannot do this in my head, so one moment while I do this on the calculator. Okay, so that gets you to 9,609,216. And you always want to double check. I'm going to double check right now to make sure I multiply that correctly. All right, cool. I got the same answer twice. All right, so and then if you need to find the volume of these concrete blocks, remember dividing those volumes. If you need to find that volume, you do length times width times height, which is 8 times 8 times 16, or the 3 dimensions multiplied by each other. And I'll do that in my calculator real quick as well. And that gets us to 1,024 inches cubed. And I forgot to label this inches cubed here. All right, and then I'll check one more time. All right, yeah, I got the same answer. And so that's just a good habit to get into, checking your work, because I used to make silly mistakes like that and get questions wrong because of it. But you won't get questions wrong nearly as often if you're doing it right, and then you check to make sure you don't do any mistakes. All right, so now all I need to do, the final step, is just use this formula we came up with at the beginning. Divide the total area, or volume, 9,609,216 by 1,024 inches cubed. And so if I do that in my calculator, that gets me to 9,333 blocks. So we need 9,333 blocks to fill this empty area here and complete the foundation. All right, just to quickly review what we've learned this lesson. So we started out by talking about volume, which is the amount of space inside an object. And then we looked at a few volume formulas, which we unfortunately just have to memorize, but a few of them were intuitive. So for a rectangular prism, you take the length, width, and height and multiply them. For a cylinder, you take the area of the base, which is pi r squared, because the base is a circle, and multiply that by the height. So pi r squared h. For a sphere, you just do 4/3 pi r cubed, which there's no trick for that one, you just have to memorize. And for a cone and triangular prism, they have the same volume formula, which is the base times 1/3 of the height, except the base of a cone is the is the area of a circle, and the base of a triangular prism is the area of a triangle. Then we looked at some tricky volume questions just to go over how you'd come up with how to solve some of these questions. I recommend that you practice some more of these questions on your own, because as you practice, you'll just develop more skills to come up with how you'd find the answer in the first place. So we had two difficult questions here, and we came up with, for the first one, that if we subtract the volume of the sphere that fits perfectly inside the cube, that gets us the area, or the volume of the empty space. And then since the length of the box is 2 times the radius, we can just substitute 2 times the radius in for the length in our volume calculations and solve for the radius in order to answer the question. And for the second one, we talked a little bit about displacement, which means that the volume of the triangular prism, when you put that and fully submerge that in the water, that volume is equal to how much water is going to spill out. So we can use that to figure out what the remaining volume will be based off how much spills out, based off the volume of the triangular prism. And then we did a tricky review question where we found that we needed 9,384, let me change that real quick, 9,384 blocks to fill this volume here. That's all I have for today's lesson. Thank you for watching, and I hope it's helpful. See you next time.